I hope that that makes sense. If not, don't worry about it. Take statistics, you'll see what I'm talking about. All right, how are we doing? Got plenty of time, plenty of time. You feel like you have a decent grasp of this, of the infinite intervals? Decent? Okay, so let me propose something else then. How about this? This time, yeah, I'll give you the function and I'll tell you what the interval is. So the function here is going to be the function, you know, I feel like being mean, not mean, but bad to you.
Thanks, guys.
Okay. So is this a type 1 improper integral? No. The reason it's not is because you don't see infinities here, right? So it's not a type 1. This looks like what we were doing before when we started class. You know, I just put up a function and, you know, we want to find the area. So we should just set this integral up. Should go from 0 to 4. Should be 1 over x squared minus 4, right? dx. That's the setup. Right? Okay. Does anybody see the issue?
It's going to have 0 in the denominator at one point.
Ah, yes. Look, your denominator, right, is going to be 0 somewhere, isn't it? In that interval. Look at this interval. We're going from 0 to 4, right? If I go in here, I'm going to have a problem in that interval. Where am I going to have that problem? At what x value will I have a problem here? At x is 2, right? At negative 2 also, but this is not in my interval, right? So at positive 2, I have something happening to my integrand, right? The thing in here is actually undefined at some point within that interval. Do y'all get that? This is what's referred to as a type 2 improper integral. So here we have a type 2. And the way you know you have a type 2 is if you have an infinite integrand. The integrand is the thing inside the integral. Does it ever become infinite? Well, if I'm trying to go from 0 to 4, I'm moving through that interval, right? I'm trying to move through that interval. Here's 0, here's 4. I'm trying to move, remember this is adding up rectangles, right? I'm trying to move my rectangles through there. And when I get to 2, oh shit, right? You got this problem, right? Because you can't have a rectangle at 2. Your function blows up, it becomes infinite, right? The bottom goes to 0. So this is how you identify type 2. Type 2 is very dangerous because you can do an integral incorrectly by not identifying that there was a problem inside of it. If you just totally miss it, like totally miss the fact that this has got a problem at 2, if you go through and do the work, you'll get a nice answer and it'll be completely wrong because you never addressed the 2 inside. I'll show that to you in this example. But so the bad news here, I guess, is that from now on, you've got to pay attention to the integrand. You can't just go and be like, oh, I'm just going to integrate. You know, find the antiderivative, You got to pay attention to the integrand, make sure you don't have any points of discontinuity, right? And then proceed from there. All right, so how do we deal with this? The way we do this is that we know we have a problem at 2, right? So I can't just run through and just integrate all the way from 0 to 4. What I'm going to do is I'm going to go from 0 to 2, but when I get to 2, I'm actually going to stop a little bit short of 2. And then I'm going to go right after 2 and then integrate to 4. So I'm going to break this up into 2 two integrals, all right? Watch the way I'm going to do this. This is going to become, that's going to become the integral from 0 to 2 of 1 over x squared minus 4 dx, and then plus the integral from 2 to 4 of 1 over x squared minus 4 dx. This would still be a problem, though. Does everyone realize this would be a problem? Yes?
You turn the 2 into like a variable?
That's exactly what we're going to do. Good. So we still have a problem here because if we ever get to 2 and try and plug 2 in, we should have a problem, right? So we're going to replace our 2 with a variable and do a limit. We're like going to approach it. We're not going to get to it. We're going to approach it. So now that becomes the limit. Okay, let me put the limit on here first. I'm going to go from 0. Let's go to t again. So the idea again is I have a problem at 2. So I'm going to go from 0 to t instead. And what's my t going to be approaching? 2. Yes? 2 from the left. 2 from the left. I erased the number line, but let me put it back up here. I can put it right here. Remember we had this number line. We were going from 0 to 4, right? We had a problem at 2, didn't we? So the first integral that I'm setting up right here, this one, is going to deal with this piece right here. And so if I'm going to move from 0 to 2, I don't want to ever get to 2, so I want to approach 2 from the left. Do you all see that? I want to approach 2 from the left, which is why I put a little negative sign here on the superscript of the 2. I'm going to approach 2 from the left-hand side. This is Cal 1 now, right? Okay. We're not done. That's just that first one. Now we need to do this one. This one, okay, should be this piece right here, right? So this time I'm going to go from 2 to 4, but I don't want to start at 2. I want to start a little bit to the right of 2. So I want to come into 2 from this side instead. So that will mean it needs to be plus limit. We'll go with, let's go with p. I like that. Okay, p goes to 2. From which side? The right side, so a little plus. Integral where to where? So bottom is p to 4, and then 1 over x squared minus 4 dx. Does that all make sense?
Just out of curiosity.
Yes.
Would it also been allowed for us to use, say, like 5 or
5 for what?
instead of 4?
You mean in the original problem, had this
Yeah.
been 5?
Oh, sorry. Oh, it's because it was negative.
Yeah, we don't have control over that.
Gotcha. Never mind.
And also I should point out that if this interval went from 4 to 5 or 4 to 10, we wouldn't be doing any of this, would we? Because we don't have a problem there. We only have a problem at 2 and negative 2. So if 2 and negative 2 is in here somewhere, you've got to address it. Understand? Yes?
If it would have been from like negative 5 to 4 or something, would you have split this up into like 3 different ones?
4 integrals. The question was if this went from like negative what, 3 to 5 and included both of them, then what we would have had was this. Let's say it went from like negative 3 to 5. Then you would have had a problem at negative 2 and at 2. So you have problems here and here. So you would have to do one integral right here, right? And you would be approaching negative 2 from the left. You'd have to do another integral here. You'd be approaching negative 2 from the right. Oh, you know what? You have to break it, maybe at 0 or something, and then go, this one would go from 2 to the left, and then this one from the right. I don't know if that makes sense what I'm writing here, but yeah, that's what you would have to do. You couldn't quite do 3. I see what you said initially. You would have to break this one because these are 2 different limits from different sides, yeah. Okay. Now, I wouldn't do that to you, okay? But the most you'll ever get is this, where you have a discontinuity inside, or you might have a problem where this went from 0 to 2. And therefore, you have the problem just at one endpoint, so you only have to do one integral with one limit. All right, I think we're good. I mean, I think we've got it all set up. At this point, it's just a matter of finding the antiderivative. Yeah. So I'll leave that on the board. So I'm actually going to, because that antiderivative is finally one that is not something that we just maybe know automatically, I'm going to come over here to the side and I'm just going to work this problem like it's its own little animal over here. Yeah, I think it's a formula, right? Yeah. Well, after I put it on the board, I regretted it because I really wanted you to do partial fractions on this, but oh well. This is formula 20. This is formula 20. What is formula 20? Does it have logs in there and stuff? Yeah. Yeah. Okay. Let's act like we don't have the formula just to do it. I mean, because it's not that difficult to do it. All I would have to do to this problem is change it a little bit, like maybe put, I don't know, something else on top, and you couldn't use the formula. Like if I put maybe like x to the fourth on top or something, or let's just keep going. All right, so this is because partial fractions, right? You check, make sure you don't need long division, which I don't. So then I factor the bottom, then I have distinct linear factors, then I go find a and b. Right, so 1 is equal to a times x minus 2, then plus b times x plus 2. And this was the one we could use a super shortcut on. So if x is equal to negative 2, we're going to get 1 equals negative 4a. I'm only writing this detail on the board because I expect you could do this. I just want to go fast through it, not expecting at all that you would work this fast with it. But okay, so does that all look familiar as to what you would do here? Okay. So I know what a and b are. I can go plug them in here. Yes? Yeah, I was going to do that today. Yeah, if you have your calculators, I'm going to show you how to do a system of equations. Let me just finish this one out. So I know that this becomes, I'm going to replace that with negative 1/4, and then replace this with 1/4. And so now that integral really becomes integral of negative 1/4 times 1 over x plus 2. I'll just do it all at one time. Plus 1/4 1 over x minus 2 dx. The reason I'm taking the 1/4 out is just because I can do the antiderivatives of these in my head, right? So what's my final answer here? Antiderivative, negative 1/4, what? Natural log of x plus 2, and then plus 1/4 natural log of x minus 2, plus c. Okay. All right, moving along here. This is equal to limit as t goes to 2 from the left of my antiderivative. What was my antiderivative? All that crap up there. Negative 1/4 natural log of x plus 2 plus 1/4 natural log of x minus 2. And then I'm going to evaluate that where? 0, t. You'll hear me say, when I say we're going to evaluate an integral, I always start at the bottom and to the top. So I always say I'm going to evaluate it from 0 to t. I hear other people, other instructors say evaluate it t to 0. It doesn't really matter. I just think, for me, it makes more sense. I'm always moving left to right. Like in my mind, I'm always integrating from left to right. So I always want to go from 0 to t, like across the number line. It doesn't matter. Just, there's no convention that we all use for it. All right, so now I have plus, and then I have to do this one over here, don't I? I have to do this one? I'm going to stop right now, though, because I already know I'm going to have a problem. So think about this. If I plug t in here, right? If I plug t in here, all these x's become t's, yes? And then I can plug 0 in and figure out that'll be a number. But imagine that these are t's, right? And let's say I let t approach 2, right? Regardless if it's from the left or from the right, if I let t approach 2, what happens right here? I get 0. Natural log of 0 is, in the limit, natural log of 0 is negative infinity. It's headed to negative infinity. The natural log function as you head to 0, I drew it earlier. The natural log function as you head to 0 dives down to negative infinity. And so what I know right now, right off the bat, is that this thing does what? It diverges. And if this diverges, the whole thing diverges. So I don't need to go through and do all the other work. I suggest you do that too. Like if you can see that one of them is going to like go to crap on you, do that one and then just be like done. Now there are problems in the homework where no, you have to go through and do all these limits. So I imagine that there are going to be some things that pop up in here when you're doing the improper integrals, like L'Hopital's rule, where you're going to have to figure out like what certain things happen as you take limits, right? Okay, I'm going to stop here because I'm going to say this diverges. I think I'll do one more and I'll just set it up. We won't go through the whole thing. We'll just at least make sure you understand what the setup is. So what about this one? This time I'm just going to give you the integral. All right, so what do y'all think here? Does this one have a problem?
Yeah.
Where? Only at 0, right? And -1, but -1's not in that interval, right? So we have a problem at 0, 0's in our interval. So if I look at it this way, I'm going from 0 to 5. I have a problem here, don't I? Which means when I do this integral, I have to approach 0 from the right. So this is going to set up, let's see if anyone can tell me just what this is with the limit right away here. I'm going to do limit is what approaches what of what? T approaches 0 from the right of integral t to 5 of this thing, right? That's the setup right there. See, we only need one integral here because we only have a problem at 0. In the previous one, we had a problem in the middle, so we had to come in from both sides, so we had to do 2 integrals. All right? And then here, you would have to do an antiderivative of this, and I do not believe we have a formula for this, so you would have to do your old partial fractions on that. I'm going to stop here for this one, okay? Oh, on the previous problem, what did we, on the previous one, didn't we, the antiderivative was 1/4 natural log of x minus 2, correct me if I'm wrong, 1/4 natural log of x plus 2? Was that it? Something like that? Okay, so remember the problem we did previously was the integral from 0 to 4 of 1 over, was it x squared minus 4 or 4 minus x squared? It was x squared minus 4 dx. That was the original problem, right? If you were oblivious to the idea that there's a problem in here at 2, if you just completely like, oops, forgot, then what you would do is you'd find the antiderivative, right? And then what you would do is you'd evaluate it where? 0 and 4, right? And if you plug in 4, you're going to get a number. And if you plug in 0, you're going to get a number. And you're going to subtract the 2, and you're going to give me that answer. And it's going to be wrong, right? Because you totally overlooked the fact that there was something happening at 2. This integral diverges, right? It diverges. So you just have to be very careful on that on a test. That, you know, you get something that looks like this, you're like, oh, he wants me to do partial fractions, just evaluate. No, 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 no. You've got to do a limit here. Yes.
Does it always diverge if it has a problem?
No.
If you divide by 0?
No.
So it's not?
No. Yeah. Trying to think of one. Well, one example would be this. Integral from 0 to, let's say, I'll make up a number, 6 of 1 over root x dx. Even 1 over x would work. But this one right here would not diverge. This would converge. You would get a numerical answer. Yes?
Earlier when you did sine of x,
I'm sorry?
when you did sine of x, you said a divergence, but if you were to shift that up to where the bottom.
You didn't have a negative?
Yeah.
You would it would still diverge because you still have the area is still oscillating. Like it's still not headed to one thing. It's like,
Still going back and forth.
yeah, it still goes back and forth. Yeah. Yes.
So, if we did the impartial fraction for that one.
Yes.
You would get like 1 over x, and then we'd stick it in there with that natural log of 0. If we spot that, like when we start the partial fractions, you would just write divergence.
Just be sure that that's what it does. Just be very sure that that's what it does. I would do a couple of homework. I think when you do your homework, you're going to see that there are some times that the natural log, you don't get 0. Like, I'm sorry, you don't get undefined. Just when you do the homework, you'll see. Yeah. Okay, we doing all right? Let's talk about the calculators. And then after that, we're going to wrap it up. We're going to call it a day. We're going to come back next week, and we're going to do a little bit more of this. Okay, so I expect that you'll go home and you'll try this homework for 6.6. All right, and then we'll come back. We'll do any questions you have over it because I guarantee you the problems in your homework are going to be slightly different. Yes.
Should we study for the test over the weekend? Just all.
Yes.
All of from.
Yeah, so study everything, yeah. This test is going to be, obviously covering stuff from after the last test, but if you look at things, like the last test, we stopped at integration by parts, right? Like that's where the last test stopped. We did basic U substitution and some integration by parts. And just a little bit of integration by parts. I'd have to look at the test. How much of it did I actually put on there?
There's 13 problems. There's 3 problems that were integrated by parts.
Were there 3? Okay, I trust you. So, but after that, you've got, trig integrals, trig substitution, partial fractions, the whole idea of the definite integral, and now these impropers. So I would say everything's on the table now, right? Because, you have to be able to do U substitution. That's kind of built in now, right? Oh, yeah, no. That's all in the past now. Yeah, it's pretty much, you should be doing problems from the homework assignments from.
The homework from 5.3 that from Monday
Mhm.
had that hyperbolic stuff again or something.
Oh, where you have to find some antiderivatives of stuff. Yeah, don't focus on that too much. Yeah, don't focus on that too much. Really, this test is it's going to be very mechanical in the sense of, I give you an integral, say find the antiderivative, right? So the majority of the test is going to be that. So you can show me techniques. I can't give you too many problems, right? How many trig sub problems can I give you and expect you to finish in the amount of time, right? So it's, yeah, 1, yeah, 1. Yeah, you better get it right. Yeah, there's kind of a give and a take on that, right? It's like the fewer problems, the more they're worth. And then I'll ask you some definite integrals, right? So I want you to be able to show me, the fundamental theorem and how to evaluate. And then the impropers will be on there. So go back and review your homework. I think in the, any quizzes I've given in class, review those. That's why I try to hand everything back to you today. Homework. I'll put together the test and give maybe some idea of how many problems it's going to be. Maybe I can send that out. Not the test, but yeah, not the test.
Practice test.
Practice, yeah. Yeah, I'll just send you all the tests. We'll just do it a take-home weekend test, right? Yeah, no big deal. All right. So systems of equations. How many of you still have your calculator today? I know I told you all to bring it last time and then. Okay, anyone's not working with the calculator? You're not, who else is not? Anyone else not have one? Is that that's your Casio, right? Is that the Casio?
I have an
Oh, you got it? Okay, cool.
I have a TA9 you can borrow. It does the same function, right?
Yeah. I mean, if you want to, you can. You're okay? Yeah. Okay. Okay. All right. So, sometimes you have to solve systems of equations, whether it be in this class or in another class. And so here's an example of a system of equations. Let's just do, I'm going to use A, B, and C because that's what we were using when we were doing partial fractions. Okay, so let's say we had to solve that system, right? Sorry, I'm just making sure my dog's not dead. Okay. Wait, hold on.
What did you just say?
Making sure my dog's not dead.
Oh.
Well, my wife's texting, to make sure, I told my wife to text me if anything came up, so. Okay, all right, back to this. So what we're going to be doing is, this is just like, we're not going to get into theory here. All this is about is, can you get your calculator to do this for you, right? So what we do is we first convert this into a matrix. So for a matrix, all we need to do is make sure that our A's, our B's, our C's, and our constants are lined up like this. So you want A's, B's, C's, constants. Once you're like that, then you can start just focusing on the coefficients. So, and then you start writing them down. So I have 2, 4, and then I don't have a C, right? On that first one, so I put a 0 there, and then I put 4. So those are like the numbers off that first row, right? And then I do the numbers off the second row. 4, -7, -1, 1, and then the last one, -1, -2, 4, 10. All right, so this is, in the matrix world, we call this an augmented matrix. The thing is, we have a way of typing this into our calculators where our calculator will solve this and tell us what the answers A, B, and C are, all right? Now, everyone's calculator, if you're using the TI-89 or the TI Texas Instrument calculators, there's like short ways to do this. I realize that. I realize that like for certain calculators, you can just have it bring up a matrix for you and you fill in all the blanks. That's all great. I'm going to show you a way that works for everyone's calculator because they're all different. And so what I'm going to have you do is pull up a function on your calculator. So you should go, you're either going to go into the math menu or you're going to go into the matrix menu. It depends on your calculator. So try and get into a math or matrix menu. So you got to find that first. And if you found it, ask, oh, you're not going to have that on there. Yeah. I checked, that one can only, I think it can only do like small systems, so I'm not sure that's even worth it. Yeah. Okay, so everyone find that? All right, so now what you do is within here, you want to look for this function, R, R, E, F. Look for that function. So scroll down through there and see if you can find R, R, E, F. Yeah. You know what? There, matrix, go to edit. Sorry, you might need to go to edit in there. Oh, you know what? Hold on, no. Go to math. Sorry, math.
Oh. Okay.
Yeah, there you go.
Then what was it again?
RREF. Anyone having trouble finding it, I can come and help. Did you go to?
Yeah, I'm on math, but I don't think.
Oh, you have a matrix menu, I think. Hold on. Yeah, your matrix is that blue right above it. Okay, so exit out of that first, quit. There, then go to math, scroll over, and then go down.
Okay.
Got that? You're good? Yeah, no, that's not going to happen. It's not going to work on that one.
Yeah.
Yeah. So just follow along. This will be on video if you ever want to watch it again. Okay, yes? No? Can't find it? Oh, you got that big fancy one. Yeah, and I'm not sure I'm going to be able to do it. Can we do that later? Yeah, I'm not sure where R. Yeah. Wait, you have the Inspire?
No, I don't have the Inspire.
What is that?
This is a
84 plus? They look almost the same, but
If you go to catalog and just hit R.
yeah, is there? But there, I don't think she has a catalog
It
key.
has this little book symbol to the right of the number catalog thing. It's a little book. Right here, see book? This little book right here is the catalog. If you're in the right menu, right? The map is not a touchscreen, is it? No. Oh, that's not what I'm gonna do. Well,
Clear RAM. What the hell are you doing? Oh, okay, so yeah.
here's your catalog.
So go ahead and hit enter, and that should take you, if you select this, okay, so select that, and it should take you back to your home screen, and you should have sitting there on your home screen RREF with a parenthesis. And that RREF stands for Reduced Row Echelon Form, which in matrix language is saying this. What's going to happen is the computer is going to do all the Gaussian elimination to turn this into something that looks like this: 1, 0, 0, and then a number, and then 0, 1, 0, and then a number, and then 0, 0, 1, and then a number. So it's going to do all this, multiply this row by this, and do add and scale, and it's going to do this where you get this reduced row echelon form, which is basically ones along the diagonal here. And so what this means is that, remember, these are the coefficients, right? This will mean that A plus nothing equals a number. So this right here is going to be what A is. And then this next one will be no A's, right? And then B, no C, so B is this number. And then C is that number. Make sense? So this, going from here to here, we're going to call that formula up to do it. So now what you need to do is you need to actually put this matrix into your calculator. Okay? We need to put this into the calculator. So I want to show you the syntax for that. First thing you do, after the parentheses, you put a bracket. And that first bracket is telling your calculator that you're about to start the matrix. All right? So here comes the matrix. Nope, it has to be a bracket. Is it above the 7? I want to say it's above the 7. No.
It has the squiggly bracket.
No. Above multiplication.
Oh, I see.
Okay? So start the matrix, right? Okay, next symbol. Bracket again. Starting the first row. Okay? Okay, now put in the first row of numbers with commas between them. 2, 4, 0, 4. Close bracket. What do you think comes next? Another bracket. Open bracket. That's your second row. No comma. 4, comma, -7. I don't think there's a comma in there. You're talking about right here, right? Yeah, I don't believe there's a comma there. Make sense? Next row. Bracket. -1, -2, 4, 10. Make sure when you're doing this, you're using the negative key, not the minus key, right? What do you think is going to come after that last row? Close bracket, and then after the bracket, close parenthesis. Did anyone get it to work yet? Hit enter. Let me see your screen. The screens are different on these, but you should be able to extrapolate the answer there. Yeah. So what did you get? What did you get your answers were? Basically A is what? 1.46 something. B is 0.26 and C is 3? Oh, okay. Somewhere on your screen you should see those numbers. All right? Did everyone get that? So the great thing about this is that in theory you could have any system of equations. Like you could have 10 equations with 10 unknowns. Your matrix would be huge, but you'd go about it the same way. Start the matrix, first row, second row, third row, fourth row, fifth row, sixth row, seventh row, eighth row, ninth row, close, close, enter, there are your answers. Make sense? Very powerful tool. You can use that. So I hope that helps. Yes?
Well, maybe we can just come and ask you after, because ours is not working.
Okay, I can come, yeah. Is there anything else? Study your homework this weekend, you know? Make sure you do your improper integral homework, all right? And have a great day. We're going to end a little early today, 5 minutes early.